So, are we live now? I sure hope so. Yep, we hopefully are. So, I'll do one more check. Yeah, it seems to work actually. Yeah, it seems to work actually. Well, I sure hope it does, but, well, I sure hope it does, but, yeah, so hey there. We're continue working on our blockchain. So hey there. And what we're gonna be doing today in this on this stream is we'll continue. So I guess the first things first, we have to split out the code. So we're successfully generating our secret key, our public key, and our address based on SHA 200 200 to 256. We're successfully getting our address in our blockchain, our secret key again, and our public key. Yeah, for now they're just arrays of numbers, of actually a byte array, which is just fine. We don't actually care about the representation, do we? The main thing is, first of all, again, we gotta have this address, and yeah, that kind of works. Again, as we found out the last time, there is a mathematical possibility to have exactly, since there is a hashing algorithm used, so there is a mathematical possibility, which is, I guess, infinitely low. I mean, 1 in 10 10 multi 10 with how much was it again, like 70 zeros or something, chance that that they're gonna be the same you see, the same yeah, and the same address. But if you manage to generate the same address, you have basically a whole access to the account. So it's basically, you basically share an account, right? Which is, well, yeah, which is kind of strange, kind of odd, but there are many things we can do about it, especially in a zero trust blockchain, which we are in. Again, we cannot trust anybody, we cannot trust any node. Yeah, so again, first things first, we're gonna be separating the whole stuff, and again, that's the part in Rust I have a really huge problem in. Especially, yeah, in all these modules and all this crappy importing. Yeah, again, sorry, but I really hate it. I really hate how the importing and exporting modules in Rust is generally implemented. Again, I'm a Java guy myself, and I'm used to Java, and I think this is one of the using packages and etc. It's the best way one can generally import, export something, etc. So let's create a folder. Let's call it core, whatever. I know. Do we have to create a mod.rs? In one of the previous streams, somebody told me it's not necessary actually. it ain't necessary. So we're gonna leave it out for now. But yeah, we'll give it a try. We'll leave it out for now, and we'll see how it will work. So the first things first. Block. Shit. Block.res. This is where the block functionality is gonna go. Where's the block header for now? First, and yeah, that's not what we need anymore. And block, and also I guess an implementation for a block, which we currently don't have. Yeah, that's fine. That's what we're gonna be doing next. Next there's a node. Oops. Let's call it state, or yeah, let's just call it a node.rs. Yeah, node state hash map transaction block. Yeah. We're gonna be importing it. I mean, in the yeah, if I'm gonna have trouble importing, I'll just ask an AI. Yeah, I'm gonna use the cheat. Let's kind of also import the account state to the node. That's what the node manages. Yeah, and the transaction will move also to transaction.rs. Yeah, that's what I'm also gonna do here. Transaction. Oh, it's still there. It's still open. Yep. So bytes key address. I mean, what we could have done is basically let's call it crypto.rs. Yeah, and the only thing we actually have left out here is a formal description. Yeah, which is basically what any blockchain node does, what any blockchain thing is. It should be mathematically deterministic. I would actually love to, if I manage to implement a real blockchain, I mean a real working damn blockchain. Well, first of all, I'm gonna publish it. I'm gonna open source it. Yeah, maybe I'll even write my bachelor thesis on it. Well, that could be a good idea. Yeah, that might be something. Yeah, and maybe it could be used. Then I will add a proper VM, aka EVM, like Ethereum virtual machine and other virtual machines with some clever and stuff. I have a couple of functions in mind which I would love to well, implement, which Ethereum does not have, and this thing does, you know. Yeah, although I unfortunately I don't completely understand the concept of gas, right? Of the well, of the, yeah, because Ethereum, I believe it outputs gas or so, whatever it's called. And I don't fully and completely understand a concept of this, but again, I think we could figure something out. At least hopefully I could. So let's cheat a bit. Yep, a small cheat. Hopefully the grog's gonna do the thing. Oh, there's no music here. Now there is. That's better. Yeah, that's even better. Huh. So core units. Oh, so it imports over the super. Yeah, that's only the syntax word I heard in Java. Super, which invokes the super constructor better. Yeah. Nope. Why? Why? Oh. Setups. It's shouldn't be here. Oh, also, yeah, we are not importing result properly, although we should. Like, anyhow. Well, anyhow. So, nope, also aren't. Digest is re-imported here. Oh yeah, obviously. We all imported digest. Yeah, that's a pardon, but it's just hilarious. Like the digest, how it's called. It's like digesting. Yeah, that's just hilarious. You know, it's funny. Yep. Sorry, gotta look up something. Yeah. So we are generating the private public key. Um, so let's call it client, and let's call it client wallet.rs. So we have address, private key, and the question which comes up is what do I do with the public key? I mean, it's gonna be used to check it, but there is no damn way I'm sending my private key out with a transaction. No freaking way I'm doing it. There is no freaking way I'm signing my transaction with a I'm sending my private key within a transaction, which is not gonna happen, which is not intended to happen. So yeah, the logical question would be what are we doing? Yeah, I'm sorry, I gotta look it up. Uh, Huh. Cancer. Lazy created. So they appear in the global state only once they have something meaningful. Meaning there is a transaction, you deploy something, or you have a non-zero balance. Until then, the account does not exist in the state. Try so not send waste space on empty wallets. You just generate a key part and nothing. The blockchain doesn't make an entry. It's a potential entry only. So yeah, in the beginning, let's store a private key, public key. Let's use utils, yes. So yeah, let's just go ahead and create some string, just like add it and oops. Yeah, this fucking convention. I hate it. That's one of the thing again I hate in any programming language. It's how it works. I only need actually a name here. Private key, public key. Yeah, this looks good. This looks good. Rest, and we're gonna be trying to do it now, like manual. Eight. Yep. Oops, there's no client wallet and client client wallet. Oh, it's yeah, it's obviously gonna be abstract. Again, I hate this. I mean, yeah, it's encapsulation. I get it, but I hate the import system. I just hate it. Like, I know how much I hate it. I just like, yeah, I'm tired of seeing how the fuck I hate it. Oops. Yeah. Oh, so it should be the file name. Fuck me. Yeah, obviously there's the stupid conventions again. Yeah. Okay. Yeah. We got something. So can I go with it? Oh, yeah, I sure can. So let's say my wallet. Yep. So my wallet. The public key, the private key, the public key, and the address. So let's create a couple of them. Let wallet 1, let wallet 2. So oh yeah. Sorry, stupid message. So yeah, we got some wallets here, my wallet and another wallet, and now we want to send some cash around. I mean, not cash, but some cheese, some money, whatever. Node state. We're creating a new node state. Ah, hey, why can't I click it? Well, I didn't like that. Come on. In Java, in IntelliJ IDE and whatever, you can click it everywhere. Okay, let's go node. The node has accounts, the blockchain, and the transaction pool. Guys, please wait a second. I'll be here very soon. So, sorry, I'm back. So, yeah, let's continue. Have private A, public A, and address A. Private B, public B. So, first requirement, one must have a fonts. Any blockchain with balances, first usually via mining, Genesis allocation, or Foss example, Alice gets 10 coins from the Genesis block. Now the blockchain state has so yeah, I need an initial balance, the Genesis block. Blockchain always starts with a Genesis block. It's block 0 in your blockchain, hard-coded or configured on a chain startup, which is the initial state. So, yeah, we gotta start a Genesis. Huh. Yeah. Here, transaction, and init initialize the Genesis block. Crap, we haven't implemented the block yet. So, new previous transactions, yeah. New Genesis, yeah. So ID 0, no transactions, no nothing. We're a plain and clean block, right? Yeah, something we can work with. Genesis block. What is called again? Genesis. I actually prefer using return because it makes the code more readable. But it does not compile because I missed the oh, oops. State. Huh? And oh. Hmm? Sorry, my bad. Huh? What the fuck? Yeah, that's what I was thinking. Yeah. Oops. Yeah, again, we're slowly getting somewhere. Wallet and another wallet. We initialize the Genesis block. Yes, that could be helpful. So, hard-coded configuration contains an initial state. Who has how much money? Yeah. So here we're gonna be hard coding the address and create a couple of wallets ourselves. This fine, 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 fine. Because I really don't like this one. Shit. Fuck it. Bring my own ideas to life. There's some. Yeah. Bros AI. Build a marketplace for second fashion while creating an app. That's a, that's a scam. This shit's a scam. What does it advertise me? This crap. We both fucking know that it's just another overpriced wrapper for ChatGPT or whatever. We all know that's a crap. AKA, was it Builder.ai or BuildMe.ai? The very large AI scam company. Also, accounts to the search. Yeah. Think is by. Yeah. Fuck me. That looks like. So. Huh? What the fuck? This account. Stream. Yeah, since we're accepting a string, that should more of a the job done. question is, why is it called Genesis? Although it should be, no, the address should be, what should it be? Zeros. Yeah, we'll do the transactions now. Then we're gonna implement this state saving. Then the hardest part, which is the networking part, is gonna happen. Yeah. The whole magic's gonna happen. And yeah, and then we'll just yeah. Maybe then we'll come to implementing our VMs and all the possible stuff. The lookup speed contains the. I hope the lookup speed is gonna be good and fast enough. Yeah, I see it just says the pure zeros. Yes, node state, which is as is, right? Build a transaction. From to amount. Okay, so now we can move to the transaction itself. So from to the amount to send, nonce, and the signature. And then the transaction's gonna be pushed. And there's these ain't strings anymore. These are this now. These are the addresses now. Oops. It's 2, it's the amount. It's the, well, the next timestamp is going to be generated then. Oops, sorry. I got a mute for a second. Pardon, I'm back. Mm-hmm. Okay. Yeah, there's some things we gotta figure out first, but yeah, that's what we're doing now. So, block. Private key we got, public key we got, address we got. Store your private key, obviously. Creating transaction is from. Hmm. Content. I got some smart idea. So from to amount timestamp. Signature. It's just a fucking placeholder. Does it think I'm joking or something? Yeah, hash would be optional, but again, we don't care. No, we don't care about it. Oops, it's too far away. Yeah, I hope you can hear me better. So yeah, we gotta hash the whole transaction content because let's say we sign the from address, but we don't sign the to address and the amount address. Um, that shit would be messy. That would be damn messy. And um, Script to utilities. Sign message, private key, and result. Yeah, I hope that should work. I'm not sure. Yes. Are we good with it? SH8 chat. Let's search this. CDSA. Sign ECDSA. Constructs a signature for message using the secret key. Message and secret key. Yeah, uh, we'll return the transaction for now. For now we're gonna be returning it like this because oh, so this thing can even fetch docs now. Not bad, not bad. Not bad. Didn't knew it can. Just use normal sign? What? Nope, we do not. Oh. Huh. We actually do. Holy shit. Yeah, that's something we need. And we're gonna also be needing later. To open Surdo? Using the Surdo? Huh? Struct. There's some unreadable code. There's definitely some unreadable code here. Some unreadable code, but fuck it, we'll go with it. Oops. Then go with it. I'm sure it will. Yeah. Missing two. Two. Yeah. Failed to resolve use of undeclared big code. Oh yeah, there was that. Decoding. Yeah. Huh? Okay, we'll go without deserialization. The traits are serialize. Oops. Okay. Action. it. Right, we have the signing, then the transaction pool, aka mempool. The node doesn't apply the transaction X right away. It verifies the transaction first. If the signature is valid. Recover the pub key. The signature verification actually works. Your wallet constructs the transaction data from two amount and nonce. It signs a hash of this transaction with your private key using elliptic curve signing ACDSA. The result is not just a number, but the pair plus a recovery ID 01. This is RSV tuple is the signature. What's inside the signature that goes in the wire? To amount, nonce, whatever. The public key is not sent. Yeah, I mean, yeah, that kind of makes sense, obviously. The public key is not sent. Given the message hash RSV, it allows you to recover the public key from the signature itself. Wow, so I can extract the public key from the signature itself. That's why the V component exists. It disambiguous in which public key was used. Once the public key is recovered, the node hashes it and gets the address itself. Oh, that starts making sense. That definitely starts making sense. Wait a second. 6K, 6K1. Yeah. We are reconstructing the public key from signature. Recoverable signature. Yeah, that really starts making sense. Okay. Okay. It starts making sense. It starts making sense. It makes sense. Yeah. Correct. Public key from signature. Yeah, and will it work? No, it will not, because method no, not. Let's go. I hope that this thing's gonna be searching for me. Yeah. Again, I would love to implement. I would hate myself for this, but we could have tried and implemented it from scratch. But again, I would. Oh. Hello there. It's been a while. Yep, it is. It's been a while since I streamed. I had a lot of things to do at the university nowadays. Yeah. Yeah, but now actually my favorite institute is gonna be dissolved, and I for streaming. Yeah. Hmm. That's some messy stuff here. Expected recoverable signature and signature. Yeah, we gotta look it up. And I hate the Rust. Uh, from slice from contact. Jest? Wait, where were they jesting it? Huh? We don't need to digest it. Oh, no, wait a second, that's a crap. That's um, we don't need to digest it. We have to, yeah. So we have to extract the signature from the crap. Sorry, we have to extract the public key from the signature, and it should be from course captured by slice to signature. Yes. It should be like this here. Recoverable signature in compact form. Serializes the recoverable signature. Um, Yeah, and again, I'm using your AI helper because I'm not familiar with these with the libraries, and that it's very hard for me to well, yeah, use them and look up like every single thing. So I try to rely on AI, but it doesn't really work most of the time. So I have to do the whole shit myself. But whatever. So again, that it's very important now to do the stuff, yeah, mathematically, deterministically. Well, then some after I will finish it, the main transaction stuff and state stuff. Then the really funny part's gonna happen. Ethereum virtual machine. You can go to C again. It's a mathematical function. State transition. It's a writing purely deterministic state transition functions and stuff. Yeah, that will be that would be fun. Let's keep it. Yep. Why doesn't it look up? It just like a couple of minutes ago. It just looked up the. Thing. Oh, yeah. Now we go. Yeah. Well, it's generated. Fine. Good. 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 Huh. So we're extracting the public key from the signature. And we are going to the to the node. And the node state. Okay, like let's implement state. Um Let me do it the other way around. Validate. Yes, whether it validates or not. Oh shit, because we're double using it. We are double using it both on client and on server, which isn't good. Right, let's. All right, screw it. Yeah. Self. Just gotta be validating. Bit content bytes it has. Address. Huh. So why doesn't it do content extract public key from the message? I mean, we could store content bytes for convenience. But for security reasons, we won't. I ain't stupid. So, just validate it. Huh. Okay. So we are guaranteed, it is guaranteed that it is valid. Well, that's something. That's something at least. That's something we can work with. So, pardon me. We extract the content bytes. We create. So, okay. Extract public key from signature. 10 bytes, and there's a signature. Good. Derived address. We convert the public key to the address. And since we can only... Fuck, that's smart. Fuck me, that's really smart. That's really damn smart. Huh. So, we are cryptographically sending the public key together and signing it with private key. And we mathematically derive, and we were sending the signature. From the signature, we're guaranteed to extract a correct public key with which we well, check the whole message integrity, and thus guarantee that it really comes from the owner of the private key without actually seeing the private key. Although that might sound ambiguous and untrustful, because oh yeah, but then we'll manually derive the derived address and the from, which basically only allows us to only act in our own name, because we cannot choose our Bitcoin address. That makes sense. Shit, that makes sense. That really makes sense. Okay, so let's save everything, and init the Genesis block. Now, add transaction, which we either result Turn. Ah, yep. 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 Okay, we're here. We're ending transaction. Okay, let's say we just added the transaction. Right. The transaction is deterministically validated. What's cool, transactions stay compact, they don't carry down the public keys, and you're not going to publicly check signatures. Security relies only on elliptic curves and math plus hash collision resistance. Yeah. Do you want me to sketch the math of elliptic curves dynamic DSA signature recovery from formulas and public higher level versus like pseudocode? Count is empty, blockchains don't register the wallet, they can't pop into existence. It's basically like stateless address solicitation in networking, but one level up with the cryptography stuff. It does exist. It was the text invalid. This sender must exist. If the recipient, you create a new account, entry on the fly with balance 0, then credit it. So, you must execute on one by one, obviously. Balance lower than the amount. Genesis block with some initial balance. We have a transaction pool, a mempool with signed transactions that have paste signature. This the transaction pool. Okay, step 1. Wallet creates a transaction. Say Alice wants to send Bob 100 from nonce must match Alan. Your wallet must look up in Alice's current nonce. Oh. Oh, so we have there. Yep. Yeah. We are creating. Okay, we're good. We're good. We're good. And now from nonce. No receives transaction. Recover pub key. Is equal from. If not, drop. Transaction added successfully. Failed to add a transaction. Why? Derived address does not match sender address. Okay. Back. That's stupid. I just forgot that just yeah. This so we're gonna collect this. Yeah, now it works. I guess we can just yeah, get the private key. Yeah. Okay, let's continue. Okay, check option. Node can be get its current state to guess whatever the stakes will be valid. If from is not in state yet, reject on hold or hold until funded. If nonce is not is state that nonce, reject replay. Nonce is more than state of nonce. Hold maybe later. If balance is lower than the amount of fee, reject. If it looks okay, add to the transaction pool. For now we're gonna leave it out because no need in that. Block assembly. Now in main minor and yeah, that's the now we came to the essential part. Start from the latest state after genesis or previous block. Okay. Big add transaction from the pool in order. Uh, wait a second. No. So let's delete it. I don't want any spoilers. I do not want any spoilers. I want to make it fine. I'll do it myself. Big transaction from the pool in order. Handle transaction. Yeah. Oh. Okay. We already got our transaction, right? For each TX, yeah, for each transaction, look up sender state, create. Okay. And sender in state. Maybe a receiver in state. If from doesn't exist, it's in the state. Check nonce. Wait, I really don't get it. If from does not exist, it means the blockchain state has no such account yet. Default assumption balance 0, non-zero. When you try to send, non-check fails unless it's 0. Balance check fails because 0. So you cannot say that makes sense. If nobody ever gave this address funds and the change state, it has nothing to spend. Correct? Yeah. So we reduce our complexity basically. Yeah. Create. Basically, let's create an account. Account state. Yeah. Again, sorry for auto completing here. I know that's not professional. But like, you know, so like small functions, I think we can all live with that. So account state AB. Where is it even defined? Just get nonce and you. Address nonce balance 0. Yeah. Equals new. Oh, oops. Yeah, sorry again. Too much coding in Java. It's way too much Java. Small runtime check. Yeah, fine. If 2 does not exist, that's totally fine. Blockchain will create a new account for 2 with balance non-zero. This apply for example walkthrough. Okay, so also note state. Address lookup. Set the address option, account state. So now let's just exist. I mean, I don't know. That should work for keys. I really hope that the runtime complexity stays as low as possible. I mean, we use just like hash. I mean, it does use hash. We already do use hashmap though. Um, we do use hashmap though. We do use the hashmap. Now I have. if, first of all, if there is no such, if receiver address, if sender address does not exist, transaction rejected, return. So we'll just reject it like this for now. If the receiver address does not exist, it's just fine. On my side, we'll just create an account. We don't want direct access anywhere. We really want to get the code. Huh. Transaction. Oops. Oh yeah. What was that? Should be can't stay there. Yeah, Rust and its goddamn macros. I mean, many say they're nice. I don't say they aren't, but I'm not a fan of them. Again, I'm the OP Java guy. I mostly call it like 85% of the time, 85. I code in Java. I prefer to use Java. I select Java. I know Java. I love Java. Yeah. So you're rejected. Accounts get mutable. No. Okay. Create accounts. Address balance. Okay. Dude, I fucking hate this syntax. Does it compile though? It does. That's alright. That's good. That's good. So transaction added successfully. node.add transaction. Then we you're confused with the zero. Oh, we haven't come to the main part here. Yeah, we should probably use the some type of priority key. We have to use the priority key here. Yeah. Oh, the iterator here is pretty cool. Process the transaction pool. Transaction. That's transactions. Equals transaction. Cool. Oh yeah, so it copies it to memory. Transaction. Yeah. We are a go. We are a go. So here it totally works. It's become a block, and what happens after? A block is a container that ties together metadata header, block number, height, genesis, uh, block in our case only, parent hash. We don't have it currently. State root hash commitment to the final global state after applying all included TXS timestamp consensus in the view validator's signature. Okay. The list of valid signed TXS is just transactions. So after you run through transactions that mutate state, you can compute state root hash and assemble a block around it. And how much transactions are in one block? Let's limit gas cost of transactions. Blocks are filled based on gas, not a fixed number of transactions of the block. Theoretically, single gas contains a mix of transactions. Huh. 1 megabyte of transactions is a block which is considered we have only like few bytes, I guess, per transaction is like a hell of a lot. But I guess we have to go with something more advanced like Ethereum. I mean, we could like stick to the whatever amount now, whatever fixed amount now, but later we could move to Ethereum and well, work with it if it's possible. Yeah, I'll come back soon. So yeah, I'm back. You know I'm back. Like field skipped. Now you can finalize the block. Parent hash, state root, yeah. Transactions. Only the successful ones, yeah. Timestamp now, yeah. Yeah, because then the hardest part's gonna start. Yeah, because now we're gonna be building our block. Um, I have an idea though, how to mm, how to store a transaction in a block. Mm. I've collected enough valid transactions, apply on the state, I'm ready to seal the block at this point. The state root is computed, the block header is filled in, consensus metadata is attached, the nonce or validator signature of the block is broadcast. There's no universal one-true moment. Yeah, the rules depend on blockchain design. Okay. Different chains. Different chains is different rules. Yeah, gas limit to a chain. You can choose options, max number of transactions, max weight, max time per block. Like all pending valid. You're keeping it simple. Yeah, that would be something. Here, reader decides if you even define a valid hash puzzle, they seal the block with whatever TXS they have and proof of whatever they add. Define a valid hash puzzle. Add your slot, turns your take, seal block and broadcast. Proof of stake and Twitch every X seconds. Huh. That's I'm still not getting it fully. Yeah. So yeah guys, I'm gonna be finishing for today. Yeah, thanks for watching everybody, and thanks for those who joined, who will maybe one day watch it or maybe not or whatever, and yeah, see you maybe next time.